Hello and welcome to another video. Today we're going to be continuing on with the Typescript line 75 and we're going to be doing minimum window substring. So in this problem you're given a string s and a string t and you want to return the smallest window of s that all the characters in t appear in. So for example, for this one here, if you look, bank contains all of the characters of t and it's the shortest string. And for the second example, it's obviously A because A is in A. And for the third example, AA isn't in A because A is bigger. So we need to figure out how to do this, right? And basically, we need to figure out how to do it efficiently, right? So let's go through this first example. And I think that's going to be the easier one to kind of go through. And I'm actually going to draw these. So let's just say it. A, D, O, B, E, code, bank. And we are looking for ABC. So the tricky part of this problem is how to figure out when you actually have like a substring with these characters. Also notice that this is a contiguous substring, in which case you would want to use sliding window first, and that's what we're actually going to do, and we're going to try to figure out how to do this with a sliding window. But how do we know really easily if these characters are somewhere in here? Like if we just have this string, we say like this is our substring, how do we know if ABC is in here? I mean, we could check like character by character, but what if there's a bunch, or like it's hard to say, right? You can't really sort. There's nothing super great. So the way we're actually going to do this is we're actually going to store a dictionary or an object in TypeScript. And what that's going to look like is, let's say this is string s and this is string t. So we're going to have a dictionary for t of every letter and its count. So for example here, we will have A with count 1, B with count 1, and C with count 1. And once we get through all these letters in t, the length of this is going to tell us how many matches we need in here to know that it's in here. So we need 3 matches, right? We need to match the counts of A, the counts of B, and the counts of C, and then we know that every character is in there, right? So we need to have every character in T in the window. So this is all the characters in T. And instead of counting, we're just gonna like keep a counter here as well. Like we're gonna keep a dictionary here. And then we're just gonna keep track of like how many matches there are total. And if there are 3 matches in this example, that means we have all of the characters. So let's kind of show you what this is gonna look like. So for S, we're also gonna have a dictionary of counts, and let's kind of go through this and show what this is gonna look like, and how our substrings is gonna work, and so on. And then we can also minimize, like, so we can have some result equal to some array, right? That's like 0 to infinity, symbolizing like the substring we want. Because ideally you don't want to store substrings here, you don't want to keep slicing. We can just keep indices of where the substring is, and then we can make it at the end. So we're just going to initialize the result to 0 and infinity, meaning like an infinitely long substring, and then we can just check at the end, like if it's still 0 and infinity, that means we didn't find anything, so we can just return the empty string. So let's kind of go through this, and then obviously we're going to have a sliding window as always with the left and the right, but I'm going to show this with just like drawing a line. So this line, for example, will mean that like the right is over here and the left is over here. But we are going to have values for that, just like a normal sliding window. So let's just show what this is going to look like. So the left is going to start 0, the right is going to start 0. So we go through A. And we're going to say, okay, well, we don't have anything in here. So let's make A equal to 1. And the other thing we need to store is one more thing. We actually need to store the length of this thing, because we need to figure out like how many matches do we need to know that all of the characters in T are in S. So in this case, the length of this thing is 3, so we're going to store 3, right? And we can just call this like matches or something. And we're going to make it 3, and then every time there is a match, we're just going to subtract 1 from it, and then once matches is 0, that means the whole thing is there. So we put in A, 1, and we check, is the count equal to the count in T? Yes, it is. This is equal to this. So that means our matches variable can be decremented by 1. So now our matches will be 2. But remember, we need to match everything, so we need matches to be 0 before we have valid substring. So then we keep going, and we add this D, and we say, okay, well, and technically you don't really have to add the D. You could do some other like slight optimization, I guess. So you could say like, if this character is not in T at all, we don't even care about it. But in our case, we're just going to add it in anyway. But if you wanted to make a slide optimization, you could. It doesn't really matter because, you know, this is only 26 characters anyway, so it's going to be constant space pretty much. Okay, so we're going to add D1, and we're going to check, does the count, like, did we make some match here? And we're going to check, is D in here? No, it's not, so we can keep going. Then we're going to add the O. 1. Is the count, is O even in here? No, it's not. Okay, we're going to add a B. Count is 1. And is the B in there? Yes, it is, right? And then if it is in there, is our count the same? Yes, it is. So then we need one more match. Then we look at the E. And for the E is not in this T, right? So we keep going. And then we finally get the C, and this is kind of like where the tricky part of the code happens. So we're going to get the C, 1, and we're going to say, oh, the C is in there as well. And notice how it's really easy to tell when a match happens, and it can't happen more than once because we are not going to allow our string to ever unmatch. Like once we have matches, we're never going to unmatch. So for example, if the C equals 1 is a match, we're never going to delete characters, so C equals 0. So it's just going to be either bigger or equal. Okay, so now the C does match, so this is matches is going to be 0, and now we're saying now our T string is in our string, and it is, right? Like we have all the characters. We have an A, a B, and a C. But can we shrink it, right? And the way we're going to test if we can shrink it is we're going to look at the left, and we're going to say, if we delete this character, was it a match? And will we still have a match? So we look here, we say, okay, this left is A. Well, if we delete the A, was it a match? Yes, it was. And if we delete it, will it still be a match? No, because this A will be 0, and then we wouldn't have enough characters. So for example, if we had 3 A's in here, we could say like, oh yeah, it is a match, but we have more than enough A's, we can delete one. That's totally fine. But in our case, we can't, so then we don't. And now we need to update our result to be, because our result string length, we have a valid string, we need to update our result, so this is like 1, 2, 3, 4, 5. So now our indices are going to be 0 and 5 is our substring. Okay, so we're going to keep going. We're going to add the O. And is the O in here? No, it's not. Okay, we're going to add a D. 2. Is the D in here? No, it's not. Add an E. 2. E is not in there. Okay, now we add a B. Is the B in here? Yes. But notice that we only add a match when these are equal. They are not equal, right? Oh, and by the way, so every time we add a character, we are going to see, every time we have a character and we have a valid match, where we are pretty much going to have a valid string from here on in, right? We're always going to maintain a valid string as soon as we get it. We are going to check, can we delete the left? And for all of these, we can't delete the left, right? Because A count is only 1, and there is a match there, so we can't delete the left. So we need to get to another A before we can delete it. And so we will do that here, where we get another A, and we're going to say, okay, it's not a match, right? Because A is 2 now. We're only going to make a match when they're equal to make sure the match stays at 0. Or you could just have some check, like once matches is 0, then you don't need to make any more matches. So here, we can start deleting stuff, right? We can say like, can we delete this A and still have enough A's to have this match up, right? The letters in S has to be greater than or equal to the letters in T now that we have a valid substring. So we can delete this A, right? So if we delete this A, then we will have 1A, which is still fine. So we can actually delete this A here, and hopefully it doesn't delete the whole thing. Okay, there we go. Now, can we delete the D? Well, yeah, because there is no D in here at all. We don't really care. So we can delete the D. We can delete the O. It's not in there either, right? So we can update this a little bit. So this is going to be 1 and 1. Okay, what about the B? Can we delete the B? Yes, because there's 2 B's and we only need 1. So we can delete that as well. Okay, so I'm just going to delete stuff and then I will update it in the dictionary. We're going to delete the D or the B. We're going to delete the E because that's not even in there. And now we get to the C. And can we delete the C? Well, no, because there's only 1. So this B and E need to be updated to 1. And now we have this string and it's 6 characters just like this string, right? So this was 6 characters and this is 6 characters, so it's the same thing. And you can see we still have ABC, but we can't delete this C anymore because that will get rid of this match. So now we keep going. We will add this N, and I'll just add it down here. So n is 1, and we can't delete the c still, and then we add the c. And once we add the c, then we can delete, or actually this c needs to increase up here. Then we can delete this c because we have 2 of them and we only need 1, right? So we're going to say let's delete the c. Can we delete the o? Yes, because that's not even in there. Can we delete the d? Definitely, because that's not even in there. Can we delete the e? Yes, it's not in there. Can we delete the b? No, because the b count is 1. So now let's actually update all these. So this becomes 1. Then the, what do we have? So d is deleted completely, so there's 0. O is deleted completely, so there are 0. So we just have a b, and e is also deleted, right? So that's 0. We just have a b, a c, an n, and a. And now this is our string. And can we delete anything else? No, we can't delete the b because there is a b in here. And if we delete this b, then this will become 0, and then we got rid of our match. But that's essentially, so you just have 2 dictionaries, and then every time you get a match, you just decrease the matches. And then while like every time you go through it, like as you add a new letter, you check, can I actually shrink it? But you have to shrink it to make sure you still have that valid substring in there. You don't want to delete it. And so now for this last one, this will be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is index 9, 10, 11, 12. So it's index 9 to 12 now for our result. So index 9 to 12. Actually, clean. I can't delete it because it'll delete the picture. But essentially, we'll rewrite down here. Our result is index 9 to 12. And then we will simply slice whatever that is, right? So we'll just slice it and return it. And then, like I said, if we still had a result equals 0 and infinity, then we could say we didn't find a match and we just return an empty string. So pretty straightforward. And like I said, some optimizations you can make. If the character is not in T at all, you just don't even have to add it. And we'll actually do that, right? We might as well. So that's what we'll do is like a slight optimization. So for every character in S that we had the counts for, if it's not in T at all, we don't really care about it, right? It's not something we care about. So we only need to add really characters that are in T, and then when we delete them, we need to make sure that their counts are fine. And that will save us some checks later on as well. So we might as well make some optimizations there just to make it a little bit cleaner. I didn't do that originally, but I'll do that now. Okay. So we're going to make 2 dictionaries, and this is a lot easier in Python because in Python you can literally just use a counter, which is a one-liner, and in TypeScript there might be a counter as well, but I don't know it, so I'm going to actually do this by hand. So we're going to have a T counter, and it's going to be a dictionary, and it's going to have a string and a number. And essentially for every string, it will just tell you the number of times we've seen it. Then we're also going to make an S counter, same thing. Record, string, number. Okay. Now we're going to make our result equal to, like I said, just 0 and infinity. And then if anything is shorter than that, we will update it to be that. So we have to go through all of our letters in T, so we can just say for let character of T, T counter. So you can also do this thing that is kind of useful. So there is no default dict in TypeScript, right? So you can't just do like T counter char plus plus because it might not be in there, but you can do this. And essentially what this is saying is if there is a character, let's use that value. And if not, let's just set it equal to 0. And then you can do T counter char plus plus. So if it's in there, let's keep the value. If not, make it 0. And either way, let's add 1 to it. Okay. So now we need to figure out how many matches we need, right? So we can just say matches equals object.keys or object.values. You just need the length, basically, of the object. And I don't know if there is a length variable for an object. There might be, but we'll just do it this way. Okay. And now we need to set the left side. So we're going to say let left equals 0. And then we are simply going to loop through, and we're going to use the right for the other part. So let right equals 0. Right is less than s.length. And right plus plus. And now we are going to get a character, and we're going to set it equal to sRight. So we're going to say let character equals sRight, just to make it cleaner because we're going to reuse it. Now, remember, we don't really care if that character is not in tCounter. So if char, or we can just say tCounter char, right? For everything that's not in T, we don't really care about it. We can ignore it. So let's do that. And then we can say, so we can do the same kind of thing. We can say sCounter char equals sCounter char or 0, just like we did on line 6. Right? If it's in there, okay, let's use that value. If not, let's initialize it to 0, and then we can add 1 to it. Okay. So now what we have to do is we have to actually check if they are equal, right? So we just updated this, actually we have to write it in here. We just updated the count, but now we have to check, like, are they equal? Are the S and T counter of that character equal? And if they are, we need to subtract one from the matches, right? So we're going to say if S counter char equals T counter char, then we need to subtract one from the matches, right? So we can just do matches, subtract, and there we go. I think it's saying that this could be, yeah, I think it's saying that it could be negative or something. Actually, I'm not 100% sure what it's saying here, because this should be fine. I guess that's kind of annoying. I'll have to run it later. Yeah, not entirely sure. That's the annoying thing about using TypeScript in LeetCode is it doesn't really like tell you your error. So we're just going to have to run it later and see what it actually is. But anyway, regardless, let's see here. Where do we actually use matches? Maybe we just didn't, we called it some, oh, it's because we used const. So we can just let, there we go. Okay. So, okay. And now essentially, now we got rid of that. And now we have to have this while loop that will shrink the string if the matches is 0. So we can just say while matches equals 0. And left equals right, but I don't even know if we need that, to be honest. I don't think we'll ever run out of bounds. Yeah, I don't think we need it. But we'll, yeah, let's get rid of it, and we'll add it if we need it later, but I don't think we do. I had it before, but I don't think you can actually run out of bounds. Okay, so now we're going to make character equals less dot left, and we're pretty much going to say, can we remove it, right? So if, so how can we remove it, right? The way we can remove it is if the counts aren't equal, right? So if tCounter, if not, tCounter of the character is equal to, and that's the nice thing about only putting in characters in sCounter that are in tCounter, we know they are in tCounter, so we don't have to check if it's in one of them or the other one. It has to be in both. Okay, so if they're not equal, then we can remove it, right? Because we're saying we already have our all of our characters in here, and if they're not equal, it's either more, in which case we can remove it, or it's less, in which case we can also remove it, pretty much, right? So I guess technically we can change this to make it a little bit cleaner. So we could say if tCounter char is greater, really, is what it would be. Like, actually, no, it would be the other way. It would be the other way. So if we have more of that character in S, then we can remove it. Yeah, it would be like that. Okay. And so we can remove it, so we can just say sCounter char minus minus, and we can move our left. Otherwise, we can no longer remove any character, so this is when we would check to see is our current string, we shrank it as much as we could, smaller than the result, basically. So we can say else, and then we can have an if in here saying if result 1 minus result 0 plus 1 would be the length of what you currently have in the result is greater than, and for sliding windows, right, minus left plus 1. Notice how these plus 1s cancel out, so we can get rid of those. So basically, if the result is longer than what we currently have, let's just use what we currently have. So we can say result equals left, right. And finally, now that we checked, so this is always going to be true. This is basically an infinite loop, like you can write while true here. So we need to break at some point, right? Once we can no longer shrink, we need to break. Okay. And finally, we need to, after this loop is done, we need to either return the slice string or like I said, we might not have ever updated this, and so if we didn't, we need to actually check for that. So we can say return. Well, let's just check result 1. If it's infinity, that means we didn't find anything, so we're just going to return an empty string. Otherwise, we're going to slice with our 2 indices, right? So that's going to be res0 and res1. So remember, res1 is the index of the last character, and for a slice, the last character is non-inclusive, so we need to add 1. Okay, so I think that's it. Let's double check. Hopefully we didn't make any errors. Maybe we did. Oh, whoops. I don't know why I submitted it. Obviously, it's not going to work. Okay, so it looks like it's wrong. So let's run it one more time. Let's just double check. Okay, so this part is fine. It's fine. Oh, I think this is the issue. So we only put characters into our S counter that are not, or that are in T. So if we get to a character like D, this wouldn't even be in here. So we need to have one more check here. So we need to basically have like another if. So we can say if, yeah, that's what we need to do. Okay. So if char, or not, I guess, S counter character, if it's not in there at all, let's just do left plus plus, right? And then we can just have an else if. Yeah, so essentially, like, if we ran into a character like D or O, these wouldn't even be in here. Yeah. I think that makes sense, so let's see what happens here. Got it. Okay. That's what we were missing. Okay, so you can see it's reasonably efficient. And yeah, so let's go through the time and space complexity for this one. Yeah, I definitely forgot that. I definitely forgot that we only put characters into S that are in T. If you put every character in there, you would just have to modify it a little bit. This is a little cleaner, so just up to you there. But let's go through the time and space. So essentially, we have to go through T. We could also do one slight optimization, right? So we can just say if one slight optimization, T is longer than S, we can just return empty string, because then it's impossible. Well, let's try that. Forgot about that. I think that might be pretty reasonable to do. Did I write it correctly? If T is longer than S, return empty string. Oh, right, length. I don't know what's doing there. Okay, T.length is longer than S.length. There we go. Okay, perfect. So it does make it a little bit better, but yeah, same time complexity anyway. So essentially, we are going through all of T. That's going to be O of T. And then we are going through all of S as well, right? But we're doing it only once. Well, technically, we're doing it twice because we have the left and the right. So worst case, we'd go through S twice. But basically, it's S plus T because you would go through both of them. You go through one to build one. You go through the other one to build the other one. And for the space, so we built this counter for T and S. But the nice thing about all these counters and all these problems that ask you to have a dictionary of letters is there's only 26 letters, right? So the length of that object will only be 26, and the length of the other object will only be 26. This is constant space because your object can only hold 26 letters. Like your word could be a billion characters and it will still only hold 26 letters. So for any dictionary you use that has constant space letters, I would argue, or just, you know, a dictionary of letters, I would argue that's constant space in any problem you have. But yeah, I think that's going to be all for this problem. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And we just got past 400 subs, so thank you guys for that. Thanks for watching.